Hello everybody, and good morning. Good morning from Sarawak, from Borneo. It's almost 11:11 a.m. here on 19th of May, 19 May 2026 on Tuesday. And today we are going to watch and witness the launch of the Vega C rocket. Okay, this one is the dubbed as the flight VV29. This one is a joint mission between the European Space Agency and also with the Chinese Academy of Science. This one is actually called SMILE, or in a very long name, the long name is Solar Wind Magnetosphere Ionosphere Link Explorer. So yeah, we are going to watch that pretty soon. But yeah, just give me a little bit of time. I will go fully live by now. So thank you so much. We will be back. All right, so thank you so much, everybody, for your patience. As I'm also still looking just slight information here and there out there, but well, it's all good. Yeah, so thank you so much for waiting almost 5 minutes here since I've already clicked the live button. So I guess let's start here. So hello everybody, and good morning. Today it's 19 May 2026 here in Sarawak in Borneo. It's 11:15 a.m. here. So today we are going to watch the launch of the Vega C rocket. This one will be the first one, the first launch responsibility. Basically, all of the, how do I say, all of the from the beginning of the manufacturing up until the launch, this one would be managed by Avio instead of the Arianespace or Arianespace, whatever you want to call it. So yeah, this one will be the first, and I really hope for the best for them. So because of that, we are going to use the live stream not from the Arianespace. We are instead going to use the live stream from the Avio's official channel. So yeah, this is at least from their channel. This is the first time ever they will do it. But of course, from the media production company, from what I know, looks like they are using from the same production company with the Arianespace. But I cannot 100% prove it yet. But let's see if the kind of style looks pretty similar to how the Arianespace also has also done with their production before. Then it means we kind of partially confirm this is from the same they're using the same media production company. But however, all of that aside, this will be one of the best mission as well. I can consider this. Yeah, this one is the flight VV29, where we are going to see the joint scientific mission between the European Space Agency (ESA) and also Chinese Academy of Science (CHAS). Yeah, nothing to do with our definition here, CHAS, because if we use our definition is CHAS, it's like you are trying to put in more alcoholic drink, and gonna put some kind of moonshine like to langkau, maybe some, if you want also you can put some whiskey in here and there, and then it's done. Yeah. So that's not the kind of definition that Charles in question is Chinese Academy of Science, where we are going to see the mission here, if I remember here, it's called the Solar Wind Magnetosphere Ionosphere Link Explorer. Yeah. And also, please excuse me for that. I'm still recovering from I'm still recovering from coughing here as well. So if you hear some kind of unintentional weird kind of pronunciation, maybe even kind of my sound needs, it's because of that. And also because my throat sort of a little bit, how do I say, itchy, kind of itchy. But yeah, I'm good. I'm still fine, fortunately. So please keep this in mind. And yeah, rather than wasting too much time, how about I just show you the kind of stream what we are going to look at today. So here we go. Okay, so this is the stream. It's going to be 8 minutes from now. In case you cannot see here, I'm going to put the full page. Let me see. Okay, so this is how it looks like. So 8 minutes left before the live stream from the Avio. So yeah, Avio will go live first, I suppose, before the European Space Agency. Okay, and rather than that, before we discuss about the mission, about the SMILE mission in the nutshell, yeah, because even then I know, I need to tell you something. I'm just a space flight enthusiast, aerospace enthusiast as well, and also some kind of stuff. But I cannot 100% say that I know everything else. But whatever I know, I give you some information. So from my search here, we are going to go with about the Vega C rocket itself. Okay, the Vega C itself stands for the consolidation. Yeah, so from the consolidation, it's basically like the culminating resulting from the original Vega mission. Okay, the original Vega has already retired like a few years ago, and now it's replaced with Vega C. And this Vega C, if I remember correctly, the first stage and the second stage is basically beef up. Okay, the first stage is basically beef up to from the P80 FW. P stands for the powder, in French in powder as well, POUDRE. Okay, And FW stands for the filament wound. Basically, it's manufactured using the carbon. How do I say? It's manufactured in carbon composite, carbon fiber composite filament. Okay, that one is the original one. The 80 in there, if you see the number, it's basically stands for the original um, propellant load target. Back then, they originally anticipated 80 metric tons, but eventually the final design, final engineering design, now it became 88 metric tons, and then eventually upgraded to P120C, which, if I remember, the first is actually used for the either Ariane 6 or Vega C first. Yeah, sorry for that. So it's either these two. Okay, where the C actually is, as you have already know, C stands for consolidation. Basically, the P120C, the 120 is the original propellant load target, 120 metric tons. But eventually, on the final design, if I remember correctly, it actually reaches 100. If I remember, 128 metric tons. So yeah, so you can see consistent 8 metric tons of additional of the propellant load there. Okay, and then eventually Vega C would be upgraded to Vega C plus. So C plus is like the midlife version between the between how do I say between the current Vega C, and then eventually with the Vega E version. Okay, which the first stage will be upgraded with the P180C. Okay, or if I remember, original target is also 180 metric tons, but eventually on the final design, still in testing, but on the final design test, it's not like in the final testing. It's basically like awaiting for the first debut flight on the Ariane 6 Block 2. Okay, that one will be the first debut flight ever for the P180C booster variant. Okay, which I'm going to show you. It's here. Oh yeah. So hello launch. Hello. 30 minutes to go and go for launch. Yeah. So hello, welcome here launch. I'm very delighted to see you here. So yeah, in case just to give you a little bit of disclaimer once again, I'm not 100% healthy. I'm still kind of coughing right now, but not 100% serious. But my throat can be quite itchy with the situation, so please keep in mind if I sounds a little bit weird. That's why, but I'll still try to keep my best. So yeah, hello launch, and hello everybody for coming in. We are waiting for the launch of the Vega C rocket for the flight VV29 that will be carrying the SMILE spacecraft into the highly elliptical orbit for the joint space science missions, on the heliophys if I remember, on the heliophysics, magnetospheric and also ionospheric study, okay, between the European Space Agency, ESA, and also the Chinese Academy of Science, CHAS, or CAS, if you really want to not be very confused. So yeah, and then eventually I want to say, let me say what I want to say. So this is the Vega C. This is how it looks like. Okay, from the first stage until the third stage, all of it is the solid rocket. So all of it is solid propellant. Okay, you can see on the middle. On the middle is intentionally being very hollow, so it can increase the surface burning rate. And then you can see on the okay, you can see on there, eventually on the top of the solid rocket boosters, on this I think there is the, yeah, so this one is the where the igniter charge goes on to ignite the solid rocket boosters. And typically on the formulation, it has three main ingredients inside it. The first one on this one is the, oh yeah, follow to mention that forgot to mention that this hollow part of the propellant, usually it can be configured with anything, but usually in very, how do I say, in a very typical scenario, usually they will design using the star hollow variant like that. Also very great to control to control the burning rate, since whenever you ignite the solid rocket propellant, usually you cannot shut it down. So of course you can only control the thrust rate and also burning rate only using the hollow geometry design, usually using the star variant. Okay, and the solid rocket propellants here, usually it powers by three main things. The first one is the ammonium perchlorate, some mostly best known with the abbreviation APCP. Okay, that one is the oxidizer part, and very good one. And eventually, and then you have the fuel itself. Not only the fuel, but also acting as the binder itself is the HTPB, which is the hydroxyl terminated polybutadiene. Okay, when also a very good fuel as well, but sometimes also can use the P-band, if I remember, polybutadiene A and something like that. Yeah, I'm not going to pretend to even know the another abbreviation of the AN, but let's just say in the nutshell, the HTPB is a much more um, sort of call it quick burner in comparison to the P-band. But either of these either of the fuel binder can be used. If you don't want to use HTPB, you can use P-band. If you don't want to use P-band, you can use HTPB. HTPB, yeah. And then and then when and then you can combine it together with the, if I remember, with the aluminum oxide metal there, just some powder of it, and then when you mix it up together, you get some kind of very cool rockets with a very smoky exhaust. Yeah, even though in the military version, usually they will use much better than the propellant that I've already described. Nowadays they're using, if I remember something about RDX, something like that, RDX propellant combination. Yeah, but again, that kind of stuff is a little bit military secrecy in comparison to what we know. Okay, and this is how it looks like. And the same, this one, if I remember, yeah, this one P120C, and then eventually this is the Zephyro 9, if I remember correctly. Sorry, this one, if I remember, it's Zephyro. If I remember, this one is Zephyro 9. This one is Zephyro 20, something like that. Yeah, but I'm not going to pretend to know it. But yeah, and this one on the upper stage is the Avum C. No, what I'm talking about, Avum Plus. Yeah, what? How do I get this a bit mistaken? Yeah, so sorry guys. So this one is the Avum Plus. This one, let's just say, like, slight improvement of the Avum upper stage before being used on the Vega, original Vega orbital rocket. Okay, this one is powered by the combination of the dinitrogen tetroxide N2O4 as the oxidizer, and with the UDMH, the unsymmetrical dimethyl hydrazine. Okay, when it burns together, usually it will spontaneously combust and then produce some thrust, but very with the exhaust color, usually it can be quite more on the reddish, on the reddish pinkish color. It can be pretty transparent as well, but very toxic. You don't really want to go this very near. Usually you will use the hazmat suit, just to fill this up before that. And then eventually with the here is the pellet fairing here. Yeah, this one is if I remember, this is a 9 meters of the of the payload Fahrenheit there, with the diameter is around, if I remember, 2 meters, something like that. Yeah, and rather than wasting too much time, yeah. So looks like it. Okay, so looks like we have the live from Avio. Okay, so this is how it looks like on the launch pad. So there are, okay, live coverage will begin at, huh, Beijing, 11:30 p.m. Are you sure? Are you sure? Isn't that supposed to be 11:30 a.m.? I think this is a mistake from the, yeah, apparently they are using the same company as well, the same media production company. But seriously, are you sure it's 11:30 a.m.? Oh, that's a weird mistake. Yeah, because if I remember, the Beijing time usually it uses the same universal time coordinate plus 8 hours, the same the same coordinate time system that we also use here in Sarawak in Borneo. Okay, so it's really really weird how he accidentally mentioned as EM, not AM. That's weird. Very weird mistakes by the media production company, but is what it is. Okay, and yeah, they are still chatting, but rather than wasting too much time, I will also going to cover just slightly a little bit as well what we want to know about it. So yeah, I've already covered about the Vega C, and this is the page. Probably I will try to put this more in the description. Yeah, I'm not able to put this on time, and yeah, some just to give you a little bit of bonus. Okay. Yeah, just to give you a little bit of bonus, this is how it looks like, the Space Rider. Okay, very cool. Something you might like to see. This one is in the future for the Vega. If I remember, for the Vega C Plus, we are going to see that soon. But for the Space Rider flight, this one would be around 2028. So yeah, it's going to be 2 years from now. And let's see if I can even cover about the Space Rider flight stuff. Yeah, and this one is actually covered from the, if I remember, covered something from the already previously, the similar design of, if I remember, used to be used to be on the flight for the first Vega flight, if I remember correctly, as well. That first flight is just to validate the design, and this one is basically just finalizing what they have already done, like decades, few like 1 decade plus ago. With From the origin flight. So yeah, this one is sort of like, let's just say, like sort of in the category of wingless space plane, just to say, but also to even call it spacecraft technically we're also true as well. Okay, and this is the integration and stuff what you need to know about the Vega C. And so that's why I said that's why the Vega, that's why Avio really plays a really big how do I say, really big role in making this rocket. Yeah, so the second stage is the Zephyro 40. Ha 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 ha. Ha 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 ha. If I don't fact check this, yeah, I sure have used these facts, Oh, but but it is what it is. We are okay, guys. So this is it. If you're very interested, you can also check this out. Maybe I should put this on the description. Okay, so you can see first stage is from the first stage until the third stage is all of those trees is the solid rocket propellant. Okay, first stage is the P120C, and then second stage is the Zephyro 40, and then third stage is the Zephyro 9, and then finally on the upper stage, the fourth stage is the Avum Plus. Okay, that one is the bipropellant, liquid bipropellant, liquid bipropellant, how do I say, liquid bipropellant hypergolic stages. So yeah, and then eventually with the payload adapter, and then eventually with the payload fairings there with, if I remember, 9 meters of height there. So yeah, and this is how the evolution looks like in the nutshell. So, oh yeah, yeah. So, so eventually they will go from Vega C. The current we are looking right now is the Vega C Block 1. And the next evolution would be the Vega C Block 2, where they are going to use the P160C. Okay, 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 okay. So yeah, and then eventually you will see in the future it will be the Vega E version as well. That one, the upper stage will be replaced by the M10 cryogenic upper stage. That one is the powered with the liquid oxygen, the oxidizer part, and then eventually liquid methane as the fuel. Yeah, so we are so that's going to be for the future. And also I'm going to cover this in the nutshell. If you're very interested, you can also look on this PDF at some point. Yeah, this one from the launch kit as well. Very interesting, but I can say it's more interactive. It's not really like super duper more interactive, but more fun, more colorful. You can look from this infographics. I can say it's sort of serving the same thing like on the website, but much more familiar and much more fun to look around. So this is how it looks like. And yeah, you can see this one, if I remember, on the boom side there, you can see that one is the 3 to 4 meters, if I remember correctly, of the boom side here. Let me see. Yeah, this one is the magnetometer, something you have already something, especially if you see from the, let's just say, from the cluster mission, from the uh, ex- yeah, from the cluster mission, from the Parker Solar Probe, and what's on. This one is very familiar and very iconic in the spacecraft design. I can say one of the influential design in the space science as well. So yeah, this one is just basically just a little bit in the nutshell how it looks like. And speaking about which, it really also, the design is as well. You see, especially the propellant and what's on, it kind of reminds me on this one, Parker Solar Probe. I mean, seriously, it really reminds me to this kind of design. Like how crazy, how crazy it reminds me on this design as well. You know, this one. Yeah, it's crazy. I actually remember this design as well. Yeah, and Parker Solar Probe is still on the operational side and not yet retired, or even slamming to the sun as part of the deorbit mechanism. I don't know. I mean, the for the deorbit mechanism, what they do if they want to, just to digress a little bit, just to in order to fully retire this spacecraft, if I remember, is that they will intentionally blind off some of the instrument eventually, and they ending the mission and let it just orbit around the sun with practically no more useful purpose anymore. So basically that's how they will retire this Parker Solar Probe at some point. But yeah, but for now, let's just appreciate it as it is. So yeah. And how do I say, let me go back on the, yeah, another from the launch kit as well, but in terms of pictures of the infographic. So this is how it looks like. And yeah, you can see they are going to observe around 45 continuous hours on the northern lights per 2-day orbit. Okay, and then more than 250 European and Chinese scientists. And then the planned mission lifetime, it's from what I can tell, it's pretty varied. It can be between 3 to 5 years, but if they know how to properly manage this program, and with more funding, probably it can even stretch 10 times more than what we expect. I mean, especially if you see on the solar observe from the Soho mission, that one is still continuous, 31 years. Originally, if I remember, it's only 5 years, but still continuing very strong till this day, managed by NASA. Okay, so this is it, how it looks like. Okay, and you can see what they are going to study about the solar stuff there, with the three main objectives there. The first one is what happens when the solar winds meets Earth's magnetic shield. This is the first question. So, and also the second, sorry, and the second mission is the how can we predict the most dangerous magnetic storms earlier? And then number three is the what causes magnetic glitches on the dark side of Earth. So this is the three mysteries that Smile will attempt to solve on this mission, and this is how it looks like with the four. Yeah, there are actually four payloads inside this mission, but in terms of the responsibility for this, who's going to do this kind of stuff mission, for the ESA responsibility, they are very responsible for the soft X-ray imager instrument to image the Earth's magnetic field. Okay, and then second is the payload module that will carry three out of four science instruments, and then later on with the integration and test facilities, I mean, you obviously know, and then eventually with the Vega C rocket as well. And then for the CAS, the Chinese Academy of Science, they are responsible for this one science instrument payload, the ultraviolet imager. Still significant contributions from ESA, but CAS also still responsible here. And then magnetometer, and then light ion analyzer instruments, and then platform, they will carry one science instruments, and then anything else that needs to function like power and steering, and eventually with the assembly, integration and testing at Aztec, and then eventually operations in space. Okay, so this is what they are going to do with the science toolbox. So they have the four instrumentation. The first one is the ultraviolet aurora imager, UVI. Okay, they are going to continuously record the northern lights for 45 hours at a time for the 2 days periods of orbit, 48 hours of orbit. If I remember, the orbit they are going to target would be, they are going to target the orbit, well, but on the highest elliptical orbit, the apogee would be the 121,182 kilometers away, and then back from Earth, if I remember, it's around 5,000 plus kilometers away. So it is what it is. They are going to record the northern lights, and then the second will be the soft X-ray imager, SXI. Okay, this one is the first camera to take detailed, long-running X-ray images of Earth's magnetic field. Okay, this one to see how Earth's magnetic shield will defend us against the dangers from the sun, and then light ion analyzer, LIA. Okay, this one is to collect solar wind particles with two sensors that measures the sun's attack against the Earth's defense, and then eventually with the magnetometer, MAG. Okay, this one is to measure the magnetic field carried by the solar wind. Basically, compare the sun's attack against the Earth's defense. So that's it. And this is the mission. What they are going to do, how they are going to image it, and whatnot. Yeah, similar to what I want to say. So yeah, and also they are going to carry one of the largest CCDs ever flown in space. This one will be cooled to negative 120 degrees of Celsius, which are developed and built by the University of Leicester, UK, on behalf of ESA, and I do have the patch as well if you want to see. Okay, I've already put it in the description on that part if you are very interested. And then eventually, okay, and then the UVI, the ultraviolet vision part here. Yeah, so because I need to go here as well. Okay, so this is the scientific legacy from what they are building, from X-ray telescopes like Rosette, and then eventually with the XMM Newton. And then with the magnetosphere monitors with the ESA cluster, with the cluster missions. Okay, also if you want to know, fun fact as well, the cluster mission is the original mission for the Ariane 501 mission, but as the history already shown, because the software were not properly tested, the main computer and the backup computer literally goes freak out with the high acceleration velocity, because it cannot convert from, if I remember, it cannot convert from the 32 bits to 16 bits of the operation. So integer overflow, and then basically the rocket turns very hard, and then kaboom, the flights goes kablam. And then that's where the ESA decided to just build identical replacement of the cluster, and then launch on board the cluster frigate rocket, Soyuz FG rocket. And the missions goes very well up until 2 years ago, when it's finally deorbit back to Earth. So yeah. And then eventually with the Swarm mission as well, 2013, I think I remember around this time. I think back around, this one is back around when the rocket was still operational back then. Yeah, I still remember around that era at that time. And then eventually with the Sun Watchers, which is the ESA/NASA SOHO mission. Yeah, that's why I said 1995 until this day, which is 31 years in operation right now. And then eventually ESA and NASA, also the same entity as well, behind the SOHO mission, they come up with the successor mission to the SOHO, which is called as Solar Orbiter, launched in 2020. Yeah, which was launched in 2020. Let me see. Yeah. And then this is going to be the mission and what's on. And rather than wasting too much time, I will rather just give you guys watch here. Okay. Okay, so it is what it is. If you're very interested, there I will also going to try to put this in the description as well. And then if you're very interested in watching, reading this, pretty dry SMILE fact sheet and pages, you can also go here, which I will try to link up. This one is in picture, so I rather give you better one. And yeah, I also found one of the interesting paper as well. This one is the this one is the very interesting white paper. If you want to read, you can also read this. I will also put this in the description, and hopefully my laptop didn't crash by the time I try to put this on the description later on, because yeah, I don't know, whatever. Is what it is. You can see the orbit here, how it looks like. That's why I said this is a highly elliptical orbit. Okay. So, and also, yeah, the perigee is 5,000 kilometers. Yeah, I was right. I was correct. Ding, 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 ding. This is good. And yeah, the same things. I forgot to pull that down. And this is the Open University. I've already put this in the description if you want to read this, because they are one of the contributor of this mission. And then yeah. And from this one is where do I got the mission patch of the SMILE mission as well. This one on, if I remember, only the Open University have this mission patch publicly shown here. So I've also put it in the description. And this one is from the University of Leicester, if you really want to see as well. Okay. And I forgot to remember the CCD, the charge coupled device. Try imagine this is something also the sensor that you use on your, for example, your phone camera, from your phone camera, from your if you're still using DSLR, also part of it contributing as well, and also your mirrorless camera, whatever camera under the sun. This is also part. This is CCD is literally on your camera to give some kind of cool picture as well. How do you get this? And also, this is the Chinese Academy of Science pages. So if you want to read this as well, you can also do this. I'm going to use it at some point. And how does it separate? It's okay. So I can give you some interesting GIF or GIF before we go for the live. So this is how it looks like if it's separated. Okay. Yeah, for launch set here, 2 minutes to launch. Okay, so yeah, looks like I should go. We are T-1 minute, so let's go, everybody. We'll go here. Okay,
Yes, I think concentrated is a better
okay,
word.
T-1
It's
minute
really
27
emotional, even if they are
seconds.
done so unique.
Okay, here we go.
Right now,
Let's go,
the
let's go,
boats are
let's go, let's
green
go.
and
À tous de
everything
DDO,
is ready.
attention pour moins 1 minute.
Okay, so this is the DDO, the launch director, giving the command for the launch. And okay, T-1 minute, 60 seconds.
Top, H0 moins 1 minute.
Mark. We have
We
60
are 1 minute to launch. We're
seconds,
live
1
at the
minute before the
European
launch
spaceport in
of the
French
Vega C
Guiana,
rocket.
and SMILE is
So,
about to begin a journey that will change how we
wish
see Earth's
the best luck for
Earth's
the
magnetic shield forever. Good luck,
Avio,
everyone.
for
Buona
the
fortuna.
ESA, and also for the CAS. Good luck for this mission. T minus 37 seconds before the launch. By now, all of the computer of the power has already gone into the power on. 30 seconds left. Okay, we are getting ready at T minus 25 seconds. All systems looks good. And at T minus 20 seconds, 19, 18,
À
17,
tous de DDO,
16.
attention pour la séquence finale.
Okay, we'll give DDO to give a final countdown.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage P
And we have liftoff. We have liftoff of the Vega C, the first launch responsibility after the of the Avio, carrying the SMILE spacecraft. Right now, launching from the Kourou, from the French Guiana, from the ELV. We have liftoff. For this joint SMILE spacecraft mission for the European Space Agency and also for the Chinese Academy of Science. We have liftoff. Okay, here we go. This
Tous les
sound.
paramètres à bord sont normaux.
Okay, here we go. Here we go. Here we go.
We have liftoff.
We have
SMILE
liftoff,
has started
and
its
looks
journey
like
on board Vega C, lighting
yeah.
up the
So
night
looks
sky
like
as it flies above the
yeah. So looks like
European
they are
spaceport
still
here
using
in
the same
French Guiana.
media
The
production
range
company.
operations
Yeah.
manager
So
telling us that
very
the
good. You can see
propulsion
the
is
optical
nominal.
tracking view here. Looks pretty nice. Looking pretty
We are
beautiful.
heading northeast
T
out
plus
over the
1 minute
Atlantic
and
Ocean,
5
and we can
seconds.
hear the rocket
By
now
now,
in
she
our
have already gone
commentary
into
box. It's
the
taken
max
us a
Q,
amount of time for the sound to get
maximum
through us.
aerodynamic pressure,
It lifts
fully
off so
exerted,
fast, doesn't
exerted
it?
to the
Tous les paramètres sont
to
normaux. La
to the
trajectoire
rocket
est
itself.
nominale.
By then, already in
And
30
we're
plus
burning the
seconds or
P120 at the moment, the
so
first
goes,
stage.
it's already
The name
reaches
comes
the
from 120 tons of
if
propellant,
if
but now it's
it
faster.
should have
It's
already
140.
reaches
It's
the
gained weight.
supersonic barrier as
However,
well.
he has a very twice to weight ratio. So
All right,
its
very
thrust
good.
is double
So
the
far, so
mass.
good.
So we have
La
2 g
trajectoire
of
est nominale.
acceleration. This means twice the value of gravity.
And we've passed something called the transonic region. What's that?
Yes,
Yeah.
the vehicle is now quicker than the sound, the velocity of sound, and now is in supersonic.
Yeah,
Pression nominale.
supersonic by now. Okay,
He's telling
T
us
plus
that
2
the
minutes
propulsion
into the
is
launch.
nominal. Everything
Okay,
is
launch is
going
pretty
well.
nominal.
We can
By now, she have
see
already burned out of
Yes.
the
we can see
burnout
the
and taper
rocket
off of
in the
the
night
first
skies
stage
here.
of
We
the
can still see that P120
P120C,
engine burning.
and we
Yes,
shall
we
get
are
ready for the
towards
Zephyro
takeoff.
40
So the stage
second
separators
stage to be
windows is
ignited.
open, and we're waiting
Get ready.
for the
Okay,
separation
looks like it.
command.
Looks like it. And looks like
Séparation
it.
du P120.
Looks
We
like
have
we have
confirmation.
ignition of.
There from the
We
range
have
operations
confirmation of
manager that we
the
have separated
stage
the
separation, and
first
then
stage, the
second stage
P120,
of
and
the
ignited the
Zephyro
second
40
stage, the
ignition.
Z40, and he's telling us
And
that
that's very
propulsion
good.
is
And that's
nominal.
what we want
We've
to see
reached
so far.
maxes.
And
Trajectoire
Yes,
nominale.
now
now,
we are 6 times quicker than the sound.
Okay, so
And we
now,
started what we call the dogleg maneuver.
Yes, the dogleg is the name of coming from the shape of this maneuver.
yeah,
It's a very steep
Tous les
maneuver,
paramètres à bord sont
and
normaux.
it's done just after the ignition of Zephyr 40 because you have very low
okay.
loads,
By now,
aerodynamic loads, and so you can also do
oh, okay,
maneuvers
okay, okay,
very,
okay.
very steep. And this normally due for safety reasons like geographical
Okay, I don't know
constraints or
what's happening
visibility constraints.
on the left side there
And we're
on
burning,
the
right now, we're burning the
telemetry
Z40,
graph,
the second
but
stage.
it is what it
Yes,
is.
and now
We have to
we are
rely
also protecting. We have also
on the
from
telemetry.
from
Okay, the altitude
with
right
some
now
seconds
is
we will be
almost 100
so
kilometers.
high that we will be
Mark
able to
100
release the
kilometers
fairing
already
because the
reaches the
fairing
Propulsion
is
nominale,
useful when you
internationally
are
defined
in
space
the
boundaries,
lower
the
part of the
Kármán line,
atmosphere. When
and
the
the
density is
distance from the Kourou
decreasing,
is
you can
almost
release the
400
fairing.
kilometers, and
And we get a
the
very good
velocity is
shot there of the
4.5
fairing. This is
kilometers per
our
second.
animation
And on the right side
of what's been planned for
is
the
the
journey. You can see the fairing is that
is the
bulbous
is the
section
timeline,
at the front of the rocket,
the
the
milestone
top of
for
the
the
rocket that's
launch,
containing our
and on
satellite. And as
the
you
Yes,
say,
middle is
it's
the
very important because
animation
it
as well.
protects the
And
SMILE
as you can
from
see,
aeroacoustic
it
vibration
looks
at
slightly a
liftoff
little bit
and from
different in
friction
comparison to
during
the
the lower part
Ariane
of the
space.
atmosphere.
Just slightly
And it
difference, but
protects from
I'll say
aerodynamic
I'll
loads
welcome
and
these
also
changes as
on
well.
thermal loads.
Doesn't look too bad, you know.
Trajectoire nominale.
Doesn't look
the
that too bad.
trajectory on the left-hand side.
On and also
The
on
green
the
line is the planned
okay,
trajectory.
we have
The yellow line, the
Zephyr
actual trajectory,
40
and that's
Image
how
du
it
burn out
Z29.
looks
and tap it off,
when we lose the
and then stage
Z40 and we've
separation confirmed,
confirmed
and then
that
we
we've
have
switched on
the
the Z9, the next stage, and
Zephyr
we have
9
jettisoned the
ignition, and we
fairing. As
have
you say, with the
separation of
space
the
effectively
payload
over,
Trajectoire
we
fairing,
nominale.
don't need it anymore.
or also payload
Just telling
fairing
us that
jettison as well.
propulsion
We
is
already saw
nominal.
which jettison
So
of the
we
9
are now
meters
burning the
of the height as
Z9, the
well.
third
And right
stage.
now
That was Zephyr
Yes,
the
9.
it's
SMILE
a very
spacecraft
powerful stage. During this
has already
phase, the
been
speed goes
exposed to
from
the
15,000 to
space environment.
27,000
Okay, that
kilometers per
that one,
hour.
this
That
one
is about
will be
30
the real
times
test of the
the velocity
SMILE spacecraft, but
of a
hopefully we
commercial
don't have
aircraft.
any
That's
problem.
fast.
Okay, so that's very
And
good so far.
we can see
We
SMILE.
can
It's
hear
the
so
gold
far.
structure. It's actually now
Okay,
exposed to the cold vacuum of space
okay,
for the first time. Can you just talk us, say,
okay.
from right
So
to
and
left
also
here
we are
again,
getting
what
ready
we're
in
looking at? On the right-hand
as
side, obviously,
it
we can
tries to
see the edge
attain to
burning, and then
the
the white structure
initial
in the middle.
Yes,
orbital
shortcutting. The
velocity,
white
Paramètres sont
part
initial
normaux.
orbital
is the
velocity. It
motors
should have
for the
already
Zephyr
gone
9 and
almost
the Avon.
almost to
Then
the
you have the black conical
almost
structure that
7.6,
is the payload
7.7
adapter.
kilometers per
This
second,
is to support
or
the
could be a little bit
payload and
more
also to
depending on
push
the mission.
it
This one is
when
just to push it
we
to
have
the
reached the target orbit, but
initial
gentle release with 4
preliminary orbit
springs.
before
And top
eventually
is
the
obviously the
stage
satellite
separation,
that is
and eventually
protected
La
the
with a
Avum
propulsion est
plus
nominale.
cover for thermal protection.
ignition
And the gold stuff
with
is,
the
Yes.
is
start
the thermal
with the
protection. And these, as I
four
mentioned earlier, these are
four
computer-generated images.
engine start
They
number
are
one.
showing
We
us
will
a
see FES1
simulation
to
of
be
what's been
begin as well.
predicted for the launcher
But for now,
in real
Zephyr 9
time.
is
It's
still
not
on the
actual camera
operation
footage from
for
space,
the flight
but
as well.
it gives us a great
And you can
view
see
of what's
the
happening in
orbital
visualization. And
velocity.
these are the
Yeah,
tracking
it's already
positions,
reaches
Nominale.
Galileo,
the
in
initial
French
orbital
Guiana,
velocity. So
and
that's very
the
good.
tracking
That's very
station
good. That's
at
very good. This is what we want to
Saint-Geomarin
see.
du
La
Maroni.
propulsion est nominale.
Getting ready for the
We
stage
have
separation.
twisted and facing upwards. Why is
And
that?
altitude is still
Yes,
rising,
this is the so-called
68
neutral
kilometers,
axis maneuver.
69
It's
kilometers.
performed just
Okay,
before the
the
separation of Zephyr
altitude right
9
now
to
rising
align
again,
correctly with
171
Zephyr 9
kilometers.
before separation and
And
make
distance from the Kourou
re-entry
is
in a
almost
predefined zone.
1,500
And
kilometers,
just
and
briefly,
the
we've also started
orbit
something called
and the
closed
velocity
loop guidance.
preliminary
Yes, you're
already
right.
reaches
And during Zephyr 9, we have the
7.67
so-called
kilometers per
closed loop
second.
guidance.
That's very good
That
for
is
the
a guidance that recomputes on
initial
board the
orbital
desired
there,
trajectory,
orbital
considering the
velocity.
actual state of the
Séparation
launcher.
du Z9.
Okay,
So it
we have
keeps us
separation of
on track.
the
Pour
Zephyr 9
l'étanchéité de Saint-Jean.
and get ready for
Now
the
we've
Avon Plus ignition.
separated the
But
Z9.
for
It's burnt its propellant. It's done its job. We don't need it
okay,
anymore. And we are now, there again is a
okay,
good view of our tracking
so it's
stations
pretty
and our
good.
flight
Looks like
paths.
it's heading to the
So,
northeast east area
Irene,
there.
right now
All
at
right,
this
that's very
point,
good. That's very good.
normally we would
And
switch
if you
on
also
the upper
notice as well,
stage. The upper
the
stage is
reason
that
why
red
Suivi
the
Stegaiu.
upper
And
you can see
there.
why.
But we're not doing that today, are we?
Yes, yes,
Why is that?
If you
indeed.
even
That's
see on
right,
the
because SMILE is quite different from
second
a
stage as well.
synchronous orbit mission.
Yeah, if you
And
see on the
so we
second
have to
stage,
wait about
oh no,
13
no, from the
minutes
third
in
stage,
costing
you see
phase
why it
before
separates pretty
igniting again
pretty late.
the Avio.
There,
And in this
there's
phase,
actually
the
pretty good
launcher is
reason
still
as well because
controlled by
it wants
all
to,
and magnetic
because
control system.
the
So we're in a
onboard rocket
coasting phase right
computer
now. And
tries to
actually,
ensure
from
that
this, we've
it's
got a good
properly
view of
tapered off
SMILE now, and you can
all of
see that
its
it's actually got a
already tell
very
off
bulbous shape to
all of
it,
its
and sort of the
excess
gold
um,
structure being kind of
thrust
very,
as well
very
before
bulbous.
eventually goes for the
It's the only way I can think
separation
of to describe it.
to
And that's actually the fuel
how do I say
tanks, isn't it?
Yes.
And we've got a
to
lot of fuel on
prevent
board
the
because we're
stages
going a
from
long way. We've
colliding
got to
each
travel
other,
a third of
which
the
will
way to the
jeopardize
moon.
the
It's a long
mission
Yes,
way.
a
completion as
very
well. So
long journey. So
that's why it's
after
been done like
the
this one,
launcher release, the satellite will have
and
to
that's
travel a
really good
lot,
as well.
up to
And for
120,000
now,
kilometers of apogee and
and now
5,000
for this mission,
kilometers of
it's
perigee.
going into
And so to do
the
this,
Apogee being the
yeah,
furthest
furthest
away,
and
away,
and
perigee being the
and
closest
the
to
for
Earth.
closest.
now,
Yes, you are
it's
right.
going into
And to do this,
the
it has to
ballistic
perform
course phase flight.
several
Okay,
racing
for the
orbit
ballistic course
maneuvers.
phase
And to
flight,
do
it means
this
that
job,
the
this propellant is needed. We have
the upper
almost
stage did not ignite first
1,600
because
kilograms of
this is a
propellant
little
here.
bit, how do I
That's a
say,
very
a little
big
bit following
amount for
in
the
the
That's a lot of
satellite.
it.
uh,
Yes, you are
a
sure.
little bit following
And so
in
did the
the
fact that it's
kind of
carrying
stuff,
so
how do I
much
say,
propellant on board,
in the
did that give you any challenges
because
in terms
it
of
Yes,
has to
designing that
some
mission?
adheres
challenges because
to the
the fuel is
orbital flight
gaseous, so
mechanic.
we have to be
That one
very
is basically
careful in order
detecting
to check that it
how do you
doesn't interrupt
fly
the launcher dynamics.
this kind of
So this is why it's
spacecraft,
important to
the kind of
simulate
rockets
and
to the
verify
orbit
every
using
detail.
as less
You've done some
as
very
fuel
good
as
work in doing that.
possible
If you just look at your
while still
screen there on the
reaching to the
left-hand
mission
side, you can see there
mission
on the
completion and
animation
using
that
as
we are
little
actually twisting
fuel as
very,
possible
very slowly. So
and try to
effectively,
be
we're
as efficient.
barbecuing.
So
And
that's
that is
why.
the technical term.
Yes, you are right. This is the barbecue, and this is used to avoid having the
Mm-hmm.
solar the solar that is facing
Okay,
always in
I'll
the
let
same
them
phase. So
explain
with the
the
barbecue, we
barbecuing
can
here.
have the same constant temperature across the launcher
Indeed, we're
all around.
barbecuing as if on a spit, rotating. Right, now, once SMILE gets to its vantage point, it'll be able to look down and image the full sunlit edge of Earth's magnetic field. It'll also photograph the northern lights, which is rather something because no mission has ever done that before. And here's the thing, it'll give us actual images of Earth's magnetic shield reacting to the solar wind. That's quite something because the magnetosphere is invisible to the human eye, so this is a
Okay,
completely new
so that's
way of
very
seeing our
good so
planet's
far. Almost
protective
T
bubble in
plus
action.
one,
I'm absolutely
almost T plus
delighted
11
that
minutes into
joining
the
me
flight.
is the
T
Director
actually
of
stands for
Science at
the
the
terminal
European
countdown. So
Space
just in case you want to
Agency,
know.
Carol Mundell. Carol, thank you
And
so
for the
much
L
for coming
actually
up to
stands
see us
for
in the
launch.
commentary box.
Okay, T plus one, 11 minutes into the flight.
Hang on a sec, I'm just switching your microphone on. Yeah, I was just saying thank you so much for being with us.
Okay,
Thanks for
so
having me here. I'm just breathless from that absolutely
so
spectacular
so
launch.
that's
I mean, we're all
basically
stunned.
a very good
And it's
mission so
such a
far.
beautiful view out there in the
At
terrace
least
and the clear blue
preliminary,
sky.
it
We just
looks
saw it
like
for
already
many,
reaches
many, many, what
the
felt like many minutes.
It was
uh
incredible. It really lit up the sky,
already
didn't
Really
it?
did.
reaches
It was
the
fantastic. So congratulations to
preliminary
our
goal for
launch
now,
team. They've
but
done a great job
not
so
yet
far. Long may that
into the
continue.
boost stage.
Yes,
We will see
indeed.
that soon
Let's see how we go.
as
11
well.
minutes and 32 seconds into launch right now. So, Carol, let's just talk about SMILE. Let's talk about the magnetosphere. Let's start at the
All right.
beginning and just explain to anyone who's not familiar what is the magnetosphere.
Yeah, so the magnetosphere is actually
Okay,
the Earth's
we'll let
magnetic field. So
much
we
more
think that the
experts
center
to
of our planet is a liquid
much more
iron
expert
core,
to
and that
actually
produces
explain
a
this stuff.
magnetic field, a large-scale magnetic field. Now, what happens to that magnetic field is it's actually shaped by the solar wind. So we have an Earth-Sun system, and the sun produces radiation and flows of charged energetic particles, and that actually shapes our Earth's magnetic field to make this protective magnetic bubble that, as you said, protects our planet and actually makes life on Earth possible. Otherwise, we would be toast.
Yes, which wouldn't be a good place to
Not
be.
really.
So effectively, then the particles from the sun they kind of bounce off the magnetic field and they fly off into space and they go around us.
Some of them do, and that's one of the big questions that we'll use the SMILE SMILE mission to answer, because obviously at the front, the sun side, the daytime side, we actually have what's called the magnetopause, and then at the back there's a magnetotail. And actually some of those charged particles sometimes leak down through the weaker magnetic field particle edges through magnetic reconnection, and that then produces the aurora and the interaction right down to the ionosphere, which is actually where the SMILE acronym comes from, because it's that solar wind Magnetosphere Ionospheric Link Explorer, which is actually what SMILE means as an acronym, and we have other reasons for calling it SMILE too.
So what's SMILE going to do, and what's it going to tell us? Where's it going to be, and what's it going to do?
So what SMILE's going to do now, obviously it's on its way on the rocket, and gradually it will actually be released, but it will then continue actually to be, over the next month, will reach up to 120,000 kilometers above the North Pole. So it'll be a very elliptical orbit. It will swing down 6,000 kilometers above the South Pole, download its data, and that will be the orbit for the next 3 years. And it will be a revolutionary transformational mission, as you said, for the first time making the invisible visible, but actually that continuous monitoring of the dynamic Earth-Sun system, taking those first X-ray images, continuous monitoring in the ultraviolet of the aurora, and then also we have 2 other instruments on board that will make direct measurements of the Earth's magnetic field to compare with the X-ray images, and a direct probe of the particles that are reaching Earth. So for the first time ever, we'll have a global system view, a dynamic view of cause and effect. And ultimately, although that's incredibly important for our scientists, and our scientists will do their work, they will pass their knowledge and insight onto more operational teams who care about space weather and the predictions for geomagnetic storms that arise when the sun goes into its most active phases and really starts to impact our Earth system.
And it's not the first spacecraft, is it, to look at the magnetosphere?
It's not, and actually we have a long pedigree. So over 20 years ago, we launched the cluster mission.
Yeah, the cluster mission.
Ariane 5, actually, from Kourou. And that was the first time we had 4 spacecraft, which was very revolutionary at the time, taking the first 3-dimensional data of the Earth's magnetic field. Also, our Chinese colleagues had the double star mission, and again, making those point measurements and giving us a little glimpse
Yeah,
of what that
I think she
system is
actually
about. We
forgot to
also have
mention
our
that
solar
the
missions, which are solar
Ariane
orbiter, which is really
501 is
studying
actually
how
a
the sun
failure.
works and
So they
what's
have to
coming from
launch
the
it
sun. So for the first
using
time with
the
SMILE, we'll
Soyuz
be able to
FG
put
rocket.
all of that together and have an
From
unprecedentedly complete
Yeah, they
global
have to launch
system
from
view.
the Soyuz FG
And this
rocket
has been quite an
using
amazing collaboration, a wonderful
basically
collaboration,
they have
hasn't
to
it, between the
identically
European
build it
Space
from the
Agency and
previous
China's?
It
previous
has incredibly, I mean,
from the
way back in
previous
2005,
Doom
ESA
mission.
and
They
China
just
signed in a cooperation agreement. So that's really the
identically just build
framework
it,
that lets
and
us
then
work together. But
as
of
you
course,
already know,
how do we
the
want to work
cluster
together?
missions
What do we
is
want to
a
do? So we've had some collaborations,
very
for
good
example,
great
Next Cluster
success so
Double
far.
Star.
So that's
We've
very
also
good. We
provided some
like to
instruments for
hear it so
Chinese
far.
missions, most recently Einstein Probe, to study new black holes in the universe. But this is the first time, and it was really very revolutionary to think about how we would devise bottom up, making and asking our European and our Chinese scientists to come together to propose a mission that would be devised, built, implemented, and operated 50-50 between our two communities.
And what kinds of discoveries are you hoping for? I mean, what makes you all feel excited at the moment?
I mean, as I say, I think, I'm a scientist by background. I've worked on magnetic fields. They've always felt a bit of a niche. They're always hard things to explain. They're always incredibly fundamental, but very difficult to study and to understand. So to suddenly be able to make images,
So
to
I've
take
already
X-ray
guessed it.
images, to take the legacy of things that
It's
we've done on
quite
other missions within
very
ESA, such as
a bit
XMM Newton, one of our X-ray missions,
challenging
take
to
that
explain
technology
as
and
well.
bring it into a
Even
new
what
sphere.
I'm doing currently
But
right
it
now
will also be measuring the
with the
interplanetary
space
magnetic
flight
fields and
stuff,
disentangling those.
it's
So I think
also
the
it can
science
be
will be
slightly
fundamentally
harder to
breakthrough.
explain, but
But for me also that real world
that's
impact,
as
because
best
at
as
the
I
moment
can
we
go
do have models of what might happen if there is a
with
solar
my
storm, how
understanding,
it
and
might
also
impact our
because my
satellites or our
background is
ground
not
electrical subsystems.
because my
But the
background
predictions are
is
not
not in
accurate enough
aerospace
yet for operational use,
engineering
because
as
we
well.
miss
I'm more on
this
the
complete
computer science,
fundamental
But
understanding of the
well,
whole
I'll
system.
try
So
my
those little
best,
glimpses
because
that
I'm
we've
very
had
interested
don't
on
constrain
this
the
topic.
models
So
well
why
enough. So
not?
for me, I think we're going
You
to
know?
see a big step forward also in the operational protection of our planet from space weather.
And just briefly, before we go, Carol, just talk us through some of the exciting things ahead in the future?
Yeah, I mean, it's so exciting to be here, Katie, for SMILE, because obviously we have so many missions coming through in our ESA program. We had our ministerial conference last year where our 23 member states came together and uplifted the science budget as a vote of confidence in the quality of the program. We celebrated our 50th anniversary at ESA, science program 51 years old now. And so actually we're answering some of the biggest questions. You know, why are we in the universe? Is there habitability? Are we alone? What's the nature of the universe? So we have a new mission that we will launch next year to look for Earth-like planets around
Okay.
sun-like stars, so solar systems like our own.
Oh, all
We
right, all
will
right.
then launch the auroral mission, which will study the atmospheric chemistry of 1,000
Yeah.
planets and other solar systems, and then we will go right out
So
to our
get
LISA
ready
mission, which is the
for the
world's first
Avum
ever
Plus
gravitational
upper
wave
stage to be
interferometer to actually
ignited as well.
sample the nature of
Get
space-time
ready.
itself. So from habitability to life out there, right through to the nature of space-time itself. I mean, it's an exciting time we have ahead.
Wow. It really is, isn't it? Watch this space. It's wonderful. Thank you so much, Carol.
Thank you,
Thank you
Kate.
very much for coming and talking to us, and good luck with the rest of the mission.
Thank you.
So to get SMILE to its all-important vantage point in space, we need to start by parking it
Get ready. Get
in a
ready.
temporary orbit close to Earth. That's where we will inject it into space, and it's going to take us about 40 minutes to get there from here. We'll need to ignite the Avon Plus upper stage twice during that time, and the
Yeah,
first
it's going to
firing
be
is scheduled
the
in a couple of
FES
minutes' time.
1 and then later on with the FES 2,
Our
which
flight
I
path,
dub this as
Irene
the
is back with us.
first
Irene,
engine start
where are
number
we?
1 and then first
Yes,
engine
now
start
we are
number
still
2.
flying
So we are
over
getting
the
ready in
Atlantic
for the
Ocean. The
Avum
launch
Plus
of
to be
them will
ignited
pass
as well.
over
Get
Northern
ready.
Europe, then across Russia and China and South Asia, reaching Australia when it will be ready to deliver the satellite. And then we continue back towards South Pacific and North Atlantic up to the orbiting when it is over Iceland.
And we're tracking the rocket using telemetry. From the moment it leaves the pad, there's a network of ground stations watching its flight. Basically, the rocket's what is effectively communicating with us, isn't it?
Yes, that's the ground station. It's how we can
Here we go. We
communicate what is the
still see
status on
the
board.
altitude is still
So they
rising,
tell us, for
but it's now
example, how the engines are performing,
431
the fuel
kilometers
that is left,
distance
the
from Kourou,
temperature,
almost
exact
7,000
precision.
kilometers, and the orbit and
He's just
the
telling us that
velocity
we
is
have picked the signal
7.37
up
kilometers
now
per
at the
second.
tracking station
Okay, the
in
tracking station
Svalbard,
already gone into
which
this
is
Svalbard,
an
and get ready
Norwegian
for the Avon
archipelago in
Plus
the Arctic
upper
Ocean,
stage to
roughly
be
halfway
ignited.
between
As you can see, it's
mainland
already
Norway and the
orienting
North Pole.
itself and the
Yes, what
spacecraft
you were telling us
to the
about the
downward side
telemetry.
there
Yes,
of the Earth.
it's
Get ready
it
in.
allows to track the flight in real
normaux.
time.
Yeah. So get ready for the Avon
And
Plus to be
telemetry is how
ignited.
we
The
know if the
first
rocket
engine
is
start
healthy.
number 1 to be initiated. Get ready in FES 1.
So we are coming up now on
Allumage
the
Okay,
next moment.
FES
We
1
have confirmation
looks like
from the
already
range operations
ignition
manager that we have
ignition of the upper stage
switched on
Avon
the
Plus.
engine on the upper stage, and
So
everything's going normally and
just for your
going
information,
well.
this is a
So
hypergolic
the Avon Plus has
propellant,
now
which
taken
the
Trajectoire est nominale.
dinitrogen
for the next
tetroxide
leg of the mission,
N2O4
and it
as
has a
the
very important job because it has to
oxidizer, and
transport
the
SMILE
fuel
to
itself
its
is the
injection
UDM
orbit,
hash,
where it
the
will then be
unsymmetrical
released
dimethyl
into space.
hydrazine, which is why it's
So this is really where SMILE's journey gets interesting,
hypergolic.
isn't it,
It
Irene?
actually can
It's a
ignite
very
it
sophisticated
ignites
Yes,
spontaneously
technology.
inside the
Avon Plus
combustion
is fully
chamber,
accurate
and it's
and also
pretty
flexible. It's
let's just say
accurate
not very
because it is
environmentally
due to the thrust control
friendly.
and
It
the
can be pretty
very
toxic,
accurate
but it's
cutoff
highly
impulse. The
simplified the rocket
flexibility is
engine
La
ignition.
trajectoire et la
due to the
propulsion
So
sont
that's
nominaux.
the only upside that we know about.
flexibility is due to the fact
And
that
also
you can
second
ignite
upside
it
is
several
the
times, up to 8
ease of the
times,
propellant
so
handling
you
as
can
well. So
really
that's why they
deliver a
use these
satellite
stages.
and then
They use this
continue
kind
your
of
mission to deliver
hypergolic
other
bipropellant
satellites.
Yes, because sometimes you
rocket
do have more than one
rocket fuel
satellite on the same
and
rocket.
also
Yes, it is
oxidizer
not this case
oxidizer
because
as well.
SMILE is
So
a
that's
single
why.
payload mission, but in other missions we had
And
released
we are getting
several
ready in
payloads in different orbits.
for the
It's
end of
like a
the
space
first
bus.
engine start number 1, or
Dropping
also
off
known
in
as the
different bus
boost number
stops.
1. We are
A
going
quick
to
word
see
about our
this
speed.
end.
We're traveling at
But by
7.39
now,
kilometers
for
per
now, what
second. It's
it
very
actually
fast.
does is
Yes,
that
30
it
times
actually
faster than a
increases
commercial
its
aircraft.
orbital
So as the tracking
orbital
stations collect the
apogee
data
here,
from the
which
launcher,
is it's
They
increasing
relayed to the
its
teams here at
own
the Guyana
orbital
Space Centre. We
altitude,
saw them earlier.
the
Sitting on the
highest
left-hand
point
side
of
of
the
screen
altitude.
there, focusing
It
hard at
tries
this
to
point.
increase itself
It's called the
using
Quick
this kind
Look
of
Telemetry
stuff.
Team, or the CVI.
So
What are
that's
they
that.
doing?
And the core
They are
distance
receiving
is
real data,
8,000,
real-time
more than
data from the
8,000
launcher
kilometers,
about
and the
propulsion,
altitude is
control, and trajectory. And
468
this allows
kilometers.
them to monitor the
The
launcher's behavior.
velocity is 7.45, and the
And they can,
velocity is
of course, confirm if a
7.41
satellite
kilometers
is
per
separated
second.
as
So
planned.
this is also what we
And
are looking so
Irene,
far.
for the first ever Vega
Yeah.
flight back in
So
2012, you were in there, weren't you?
we are still
Yes,
here
you're
as well.
right. I was in CVI 14 years ago. So in 2012, for the first flight of Vega. So it was really impressive for me to have this dream becoming reality, because I was seeing all our simulations that
Okay,
were
and
really
the altitude is
becoming
still
true
rising,
in our screen.
475
wonderful.
kilometers.
And they have their own
And the
internal
velocity
comms link,
already
so they
added
pass the
around
information and the
already
confirmations
added 20
and the
meters per second.
milestones to the range operations manager, and who then announces those confirmations
Okay,
to the
added another
base.
10 more meters per second.
So we
The
are now getting
velocity
closer
is
to switching off
7.44
our
kilometers per
engine.
second.
How
Altitude
does
is
it know
480
to
kilometers.
Yes,
And
the upper stage
cruise
has its
distance is
brain, that is the
more
onboard
than
computer.
8,500
So
kilometers.
it's what brings the launcher to life. Without it, the launcher
Okay,
will be just an
and
amount
we are
of
still
structures,
burning in the
propulsion,
propellant of the
wiring,
Avum
without
Blast upper
no
stage
way to
here,
function as a
here
system.
right now.
So this is why we
The
can have
hypergolic
a real mission
bipropellant
from
rocket engines are
liftoff
still
to the
doing its
orbital,
job
thanks to the
on the
onboard
upper
computer.
stage.
So how does it actually execute that mission then? I mean, how does it know where it is, what it's supposed to do?
Yes, the functions that are inside the onboard computer, the main functions is the navigation, guidance, and control function.
Well, that's your speciality,
Yes.
isn't it?
The navigation provides you the positions and the attitude you are sensing through your inertial measurement. The
Okay,
guidance
still going
provides
with
you
the
the
Boost 1
the
phase
desired
flight
trajectory
with
to
the
be
first
followed,
engine start
while the
number 1.
control
We shall hear soon the
tracks the trajectory to
the
be
fourth
followed
engine cut
thanks
off.
to the actuators.
Sorry,
So the
correction
transvector
of the.
control
It's
and the
not
action
first engine
control
start.
system.
It's fourth engine cut off.
So this is
First
the
fourth engine start and then fourth engine cut off number 1. So we have
the moment we
already
switch
the
off
FICO
the
1,
engine on the
also
Avon
known as the
upstage. We have that confirmed.
right now the end of Boost 1
And
already
so
initiated.
we have now entered again another ballistic phase. That
Yeah,
means we're
another
traveling without
ballistic
propulsion.
course phase
We
flight.
are coasting
No engine
without
ignition
the
so far.
engine.
This one is to
So
optimize
we're
the
about
amount of fuel that can
25
be
minutes
used.
now
So
into the
later on, it can
flight, but
slingshot
of course the
itself
teams
into
have been
much,
working
much,
here at the
much
spaceport
higher
for weeks and weeks, getting the rocket and the
stable
satellite
orbit.
ready for
Okay,
today's launch.
both
We
for
call
the
that process the launch
perigee, the
campaign.
lowest point of
Yes,
the
we can run
altitude,
several
and
launch
also
campaigns in
for
parallel
the
here
highest
at
point
the
of the
European spaceport.
altitude.
This
You
is
know,
very
the
good for our
perigee
customer
and
because
apogee,
they can increase
that
our launch rate.
respectively.
He's just telling
And
us
the
that we're
altitude right now is
orientating for the
503 kilometers, and the cruise distance
So,
almost
the
9,400
parts of
kilometers,
Vega
and the
C are built
velocity
in
is
Italy and transported here to the
7.46
Guyana
kilometers
Space
per
Centre, where
second.
they're assembled.
Yeah,
What's been
so
happening
pretty
during
fast
the
there.
launch campaign?
Yes, the
Okay.
Avio upper stage and the shell of the first stage, the
Okay, so hopefully
P120,
this is
arrived
not
on board of
a
a
very
sailing ship
copyrightable song
called
because
Canopy.
I'll
The
be a
P120
bit
was
problem
then transferred to the launch
if
zone
this is it.
slowly using a special track.
But even then, the
other
the
stages
kind of
arrive at the port
copyright
of
song,
Kourou on
at
board
least
another
if it
ship,
doesn't take down
Colibri.
the stream,
The Zefiro 40
I'm still
traveled
okay.
by truck to the launch pad,
Okay,
where it was
so this is
tilted
how it
and
looks like on the
integrated
launch campaign as
on
well.
top of the
You can
first
see
stage.
how they assemble.
The integration platform for
So
Zefiro 40 is
they
about
are
29 meters
they are
from
doing
the
this kind of
ground.
integration vertically as well. You
We
can see
follow
how
the
this is
same logic with the third
this is
stage,
how they
that
are
is the
doing.
Zefiro 9 is
So, yeah.
transferred to the launch zone, then is tilted and lifted onto the second stage for the integration
Alright,
on the platform
alright.
at 35 meters. Finally, Avon arrived in its container by road, is lifted on the upper platform at about 40 meters from the ground level and mated on top of the third stage. You can
So
see the
so
platform
this is the
inside
process
mobile
how they are
gantry that give the
assembling
teams access
not only
to
the Vega
launcher.
C rocket but also assembling the
The SMILE arrived in French Guiana by
assembling the
boat.
SMILE
It went to the
spacecraft.
dedicated satellite
So-
preparation
so
building
this is
at
how
the
it looks like.
spaceport, where it was carefully unpacked. The teams wore protective suit to fill the tanks with propellant. They tested SMILE and mated with the payload adapter. And finally, the whole thing is enclosed inside the fairing.
Yeah, so you can see this is also the Avio team also assembling
And
it as
finally,
well.
the whole thing was enclosed inside the fairing. The ventilation inside the
Okay,
fairing
so
was
this is
then
how it
adjusted
looks like.
in order to assure the best condition for the spacecraft. And once completed, the payload assembly is transferred to the launch zone and lifted and mated on the top of the launcher.
And the range
Okay,
operations
so
manager
already
was just
finished
confirming
the
there that the orbit
video as well.
is correct. So
And
behind
all of
every
it
launch
looks pretty
campaign
fine,
and
looking
countdown,
pretty
there
good
are all
as well.
kinds of
We can
people
see there
involved.
as well.
People involved in building the satellite and the rocket. Their expertise carries the launcher and satellite from the factory floor to the launch
So
pad.
yeah, we
Yes,
can
it
see
only
there.
takes a few seconds for a rocket to lift off from the pad.
So
But
pretty
every
good.
launch is built
So
on
far,
aerial
so good.
expertise and
And
dedication
the
from the
altitude is
team.
535
The
kilometers.
Avio teams
The distance
manufactured
from
Vega
Kourou is
and designed
10,000,
the mission, so they
more
know
than
the rocket better
10,500
than
kilometers,
anyone.
and then
They've lived
the
every
velocity is
challenge. Let's step behind the scenes
7.43
and meet some
kilometers
of
per
them.
second. And later on, we will also getting ready for the start of Boost 2, or also known as the and also for the fourth engine start number 2, and then followed by the end of Boost 2, also known as the fourth engine cutoff number 2. So, and after that will be the small separation, but small separation it will happen around, let me see,
is to bring safety rules into reality.
it should happen around 50 minutes plus into the flight. We will see that soon as well.
Our engineering
So
team
yeah,
works hand in hand
it's what it
with
is
our
as well.
partners from Avio in such a way that we respect the right level of quality, from the mission preparation to the manufacturing of the stages to the integration until the launcher is ready on the pad.
My most important responsibility is ensuring coordination across all teams. So I focus on the strategic decision making to keep the ground availability aligned, safe and efficient.
When we see Vega on the launch pad, we have a sense of pride and satisfaction of the work done. But at the same time, we have to be cautious and content, because we have not yet completed the mission, and only when we see that the spacecraft has been released on the right orbit, we leave way to our joy.
It's a powerful mix of responsibility and pride. You feel the weight of every decision,
Fin de
but
visibilité
also a glimpse of
Svalbard.
achievement, knowing the efforts of all the teams
Perte
comes
attendue
together
de la
in that
télémesure
final
pour
goal.
environ 22
rocket
minutes.
is extremely powerful, and you put on top your satellite that you've been working on for 10 years, and then you send it to space. So of course it's extremely exciting. It's super exciting.
I feel like I do the
Yeah, so
best
this is what they
job
are
in the
talking
world.
about so far.
It's a mix of
So good.
focus and pride, which turns sweat into emotion.
But it's also a little bit sad because you are basically saying goodbye to the child that you've been working on with the hundreds of people in your teams in China and Europe, and it has to accomplish its mission, which it is designed for. So I'm sure it will be all okay.
Oh, so much passion, so much dedication. Right, we are going to take a break. We're going to be taking a break for about 16 minutes, about quarter of an hour.
All
So we'll
right,
come back to
16
you
minutes from now.
in
So
at 1:39
very good, very
a.m.
good, very
here
good.
in
I will
Kourou.
be
That
back
is
here around 15 minutes
4:39
from now. So
Universal Time.
that's very good.
6:39 in Rome, Paris, Central European Time, and 12:39 p.m. in Beijing. See you back here then. Don't go away.
You.
All right, so looks like it. And we'll be resume again at T plus 47 minutes, which will be 15 minutes from now. Okay, so why not? I'll go take a bit of break here. So yeah, see you guys. We'll be back soon. Thank you, and stay tuned as well. And we'll be right back. And yeah, just to give you a quick update, the mission right now, the altitude is 576 kilometers. Distance from Kourou already passes more than 12,000 kilometers, and then the velocity is 7.38 kilometers per second. So this is it. We will see soon, less than 15 minutes from now. So yeah, see ya. We'll be back again. Hello, hello everybody. I'm back again. We are going to see the resumption of the live from their side as well. We are going to see that soon. So yeah, five, 4, 3, 2, 1. Should be resuming back again, and the altitude is 692 kilometers. And this is the live replay here. Wow. Okay. That's a little bit of surprising for my eardrum, but yeah. But fortunately, it looks good there. So very good. You can see there.
Really a milestone, It is really a milestone. Can you hear me?
All right, nice. You can see there. This is the launch replay of what's happening almost 50 minutes ago. Here you can see there. All right, nice.
Welcome back to our YouTube live Vega Go. We are 48
So
minutes into the journey
yeah,
of
like
SMILE
let's see if we are
spacecraft
going
aboard
into
Vega C on its way
the
to its orbit. I'm Katie
uh
Haswell.
how do I say,
Joining me still,
the
Irene
fourth engine
Crociani.
start
Irene
number
Crociani
2, and
from
then
Avio.
after that,
Irene, it was a
also
beautiful
known
launch,
as
wasn't it?
Yes,
the
indeed. A very
boost,
beautiful launch. Up
start
to
of
now,
boost 2,
everything
and then
was as
followed by the
expected. We lifted off
end
at
of boost 2,
52
which
minutes
will be
after
culminated
midnight here
into
in
the
Kourou,
fourth
and
engine
then we
cutoff
separated to
number
three
2,
stages
and then
nominally.
after on
Then
it
we
will
had the
be
first Avon burn,
going with
leaving
the
the
small
launcher in the
spacecraft
Suguwa
separation,
transfer orbit,
which
where we are now.
which the mission will
And
sort
the
of
next phase will then
already
be to sort of
begin,
head
but
towards the
not fully,
separation.
as
But
the mission is
first of all, let's just take a look
still
and
needs
see
to
what
go into
has
the
happened
much
so far.
higher
Get a look at the story so far, if you
elliptical
like, and
orbit.
what's planned
So for this
for the
mission,
mission
for now,
upcoming.
it's going into the initial highly elliptical orbit. So that's that. And we are looking back another one here as well. Okay. So looks like an animation there. Yeah. Let's see. You can see on the payload fairing decoration there with the mission patch and whatnot. And currently, right now, the altitude is 700 kilometers. The distance from Kourou is almost 18,600 kilometers, and then the velocity is 7.25 kilometers per second. Okay, and you can see all of the animation on the screen there. The CGI there is basically just outlining in the nutshell about the mission. Okay, up until this point, and you can see there, and then eventually will be culminating into the separation of the SMILE spacecraft. So that's going to be the missions, and then eventually with the solar array panels deployment as well, followed by the signal acquisition of the spacecraft, tracked by the ground station eventually. All right. Okay, so I believe the small spacecraft just passes us by here in Borneo. So it looks like hello and welcome, Smile spacecraft. Hello, welcome. And we shall see the Avon Plus upper stage to be ignited soon as well. We will see. Okay, and you can see eventually the deployment as well with the magnetometer. If I remember, 3 to 4 meters of the boom itself being deployed as well. We shall see that soon. All right, so that's that.
So that gives us a really good idea of SMILE's elliptical orbit and how it's going to climb higher and higher into space. So coming up on the next key event, the
Acquisition de la
second
télémesure par la station New Norcia.
Okay,
ignition, and the
get ready for the
rate
ignition.
operations manager has just told us that we have picked up the signal now at the New Norcia tracking
Tous les
station,
paramètres à bord sont normaux.
which is in southwest
Okay,
Australia.
so right now,
our flight path has brought us
the
down to
rockets
Australia,
and the payload are now pointing
and the
upward,
teams there
just
now
in
tracking
preparation
all
for
of
the
those
Orientation en vue du
phases.
deuxième boost avant.
for the
So what's
ignition.
happening up there in space? He's
In
just
preparation for
told
the
us we're
ignition.
orientating
Yeah,
for the
so
next
I was
boost.
correct there.
Before we were
I was correct.
barbecuing to keep constant temperature all across all around
Okay,
the
the
launcher.
altitude is
But now we are
705
started
kilometers.
pointing
The
for
distance from the Kourou
for
is
the right attitude to prepare the Aum second burn.
62
And
kilometers.
barbecuing,
It's
of
now
course, just a
minus out.
reminder,
And
is
then the
a
velocity is
rotation to keep
7.25 kilometers
the
per second.
temperatures nice and even, because it's
Get
very
ready
hot when
for
you're
the
facing
start
the
of
sun and
boost
very
2,
cold when you're
aka
facing
known as the
space.
fourth engine start number 2. Get ready in.
Deuxième allumage de l'avant.
Confirmation that the second
Okay,
Propulsion
burn has
nominale.
occurred.
already
The Avio
confirmed
Plus upper
ignition of
stage
the
has
Very
Avum
good.
Plus upper
Very
stage.
good. This
Already
burn is quite
confirmed the
short.
ignition of
Démarré
it.
nominal.
It was just
Okay.
a couple of minutes, and this used to
Yeah, just couple
put
of
the
minutes.
launcher in the circular orbit where we will release the satellite.
Not really super duper like
Our speed
two
there on the
circular
bottom
orbits,
right-hand
more
of
like
the
the
screen,
highly
7.27
elliptical
kilometers per
orbits, but
second,
not
and right
really
now we're
super
at an
high
altitude
at that
of
point. At that point, it's just more like in the
705 kilometers. So
in the
we're nearly on our
pre-initial flight.
separation orbiting
So
line.
later
We've
on,
got to
with
deliver
the
SMILE
onboard
onto
thruster
exactly the
propellant
right
of the
orbit in the correct orientation
SMILE
down there, so that
spacecraft,
we
that's also
set it
going
off, if
to
you like, on the right
bring it
path.
higher and
The
higher
upper
upward up
stage
until the
extremely
100 and
accurate in delivering the
up until
spacecraft,
the final
thanks to the
orbits later
precision of
on,
its
which will
propulsion
be
system,
culminated
actuators, and
5,000
navigation. And
kilometers
after
by
separation, SMILE will continue its journey alone to reach the final orbit, the highly
1,182
elliptic
kilometers
orbit, shaped
at
like a nova.
its
Indeed,
highest
and the furthest point, as you
orbit
said earlier,
parameter.
is
So that's basically it.
120,000,
It's going to be like that.
121,000
We are
kilometers above Earth,
we are still
and its closest point
adding the velocity
5,000. But why does it have to come so close to
7.31
Earth?
kilometers per
Yes,
second.
so an elliptic
So
orbit is surely
here we
less
go.
energetic than a circular orbit, so it takes less fuel for the satellite to arrive there. And then you have a very long time staying at high altitude, so you can take the image you need for the magnetosphere.
Okay, so getting
And
ready
then
in
when you
for
approach
the
at
end
the
of Boost
perigee,
2,
the
aka
Earth, you
known
can
as the
download the
FICO,
data
the
in an
fourth
efficient way.
engine
So it's a
cutoff,
very
number 2.
clever
Yeah, so
orbit.
get ready in. We shall hear that soon.
Our
The
trajectory
Avum
on the
Plus
top
upper stage
left-hand side of the
will
screen,
be
the green
cut
line, our
off.
planned trajectory, the yellow line, our
And then,
actual
yeah,
trajectory
looks
down
like it.
there.
Looks like it. Let's hear
Deuxième
soon.
extinction de l'avant.
Okay, so
And we
already
have the
confirmed.
second
The
extinction
Avum Plus upper
confirmed.
stage
We
has
have
already
switched our
confirmed
Orientation
cut off.
correcte.
and he's telling us that the orbit
Okay.
is correct.
D'orientation en vue
So
de la
this is good.
séparation du satellite.
This is
You can
good.
see the New Norcia tracking
We will
station, and
see
he's just
the
announced there the beginning
deployment
of
of the SMILE
orientation
spacecraft. Let's see.
Yes.
for
It's going to
separating the
happen soon.
satellite, is that
Yes,
right?
you are right. Before we can separate the spacecraft, the launcher needs to be with a real precise pointing. So it is needed to orient towards the
Okay.
sun, the solar
Okay,
panels
so
when
looks
they
like the
will be
altitude is
deployed.
slightly increasing.
And the
706
launcher
kilometers per
orients it
sec.
thanks to the
Sorry,
reaction
the
control
altitude is
system. That
706
is
kilometers,
pointing
and
system for the
the
ballistic
velocity is
phase. And this is
7.34 kilometers
important
per
because
second.
we have to be very
And the
stabilized
distance
when we
from
release
Kourou
the
right now,
satellite.
it's
And the regular
minusing
rates shall be
almost
very low,
80,200
under
kilometers.
1.5 degree per second.
And how does
Okay,
separation
de
so
l'orientation.
slight spin
So the
here.
separation works with the four springs
This
in
one,
the
this slight,
payload adapter. We have four springs that gently
this
push
slight,
the
how do I say?
satellite to
Slight
have a safe distancing
rotation
from
orientation
from the
here
launcher
is just to stabilize
towards the
the
satellite.
spacecraft.
And so
So
this is really
that's basically how it
important
does.
to keep
Get ready
the
in for the
safety
SMILE
of the
spacecraft
release.
separation from the Avum Plus upper stage, and also from the payload framing payload adapter there.
Séparation du satellite SMILE.
Okay, so looks
And let's
like
confirm
the
that we
SMILE
have had
spacecraft has already
separation
separated,
of the
and the
SMILE
La séparation
satellite.
correcte.
altitude right now is currently
And
707
SMILE,
kilometers,
you can see it
and
there
the crew
moving
distance is
gently away
7,280
from the
kilometers and
mothership,
downward,
having
and
been sent
the
into space
velocities
by a
should
set of
be in
spacecraft
7.34 kilometers per
that
second.
you
So
just
that's very good.
described.
That's
And
very
he's
good.
just said we're
That's a very
starting
good sign there.
the moving
So
away
yeah,
move.
it's
Yes,
moving
we have
away
the collision
slowly,
and
one by
contamination
one,
avoidance maneuver
and the
after
Avum plus upper
separation in
stage
order to
will,
be
which
sure to
will
stay
eventually
far
be
from the
specified,
satellite.
and the
So the teams at the
and the
Chinese
degassing
Satellite
of the
Control
propellant will
Center
also
and the
begins
European
on the
Space
Avum plus upper
Operations
stage,
Center
and
will then
eventually
be
will be
taking on
re-entering
their
back
new
to Earth,
satellite. They'll be going through a
and
process to
presumably
check
even
its
before that
health.
should be Avum plus.
Yes,
Avum
the
plus
spacecraft
should
operations
also
will now
be
progressively take control of the satellite. They will deploy the
ignited
solar
one
panels,
more
perform
time
some
just to
tests,
do the
and verify that everything is
destructive
functioning
re-entry
properly
burn
on board.
back to the Point Nemo,
So now we need
which will be
to
re-enters
wait
back to
for
that area,
confirmation that SMILE
Point Nemo around the
is sending its
Pacific
signal,
Oceans, just to
and also confirmation
that's basically has
that it
no
has deployed its
civilization,
solar
no
panels.
islands,
Yes,
almost
this could
nothing there.
happen while we
So
are
hopefully
still in the range of New
everything is safe
Norcia,
there by
that
the
is
time it
within
re-enters
7
back,
minutes
as the
from the
debris
separation,
basically scattered
and otherwise we have to wait.
around the area.
But
Okay, so it looks
our
like they are
things,
clapping around, and
We're
the mission
getting
already
some very
fully
happy
confirmed
faces
yes,
as well.
and some
So it looks like
so
the
I
claps,
signal
think
acquisition also
which
already confirmed as well.
makes us think that
So
we're
that's very
maybe some
good.
good
Confirmation de
news.
l'acquisition du signal satellite et du déploiement des panneaux solaires.
Yeah, so already confirmed. Also
Fantastic
with the
news.
solar
fantastic
array
news.
So the
panels
range operations manager has
deployment as well.
announced that we
Already
have
confirmed. Already confirmed.
received the
Fully
signal from
on
the
full at this
satellite,
point. So
and
that's
we
very good
deployed
to
the
hear.
solar panels. So that's
So
wonderful.
wonderful news. Everything is perfect.
Yeah, so the
So
launch is
huge
perfect.
congratulations
Very
to
good.
so many different teams
And yeah,
involved in
especially
today's
congratulations as well to
mission.
Avio for
It's a very, very important
successfully done
satellite,
this
and it's
launch
also a very
responsibility.
important day for
Looks like
Avio
it's a pretty
because today
perfect
Avio became the first
under
launch
Avio's
provider as
Avio
well as
responsibility
a
launch as well. So
manufacturer. So it's
congratulations as
very
well,
well
and
started.
congratulations to the
Yes, you're right.
European Space
Congratulations
Agency
to the
and also to
Chinese Academy
the
of
Chinese
Science, the
Academy of Science
European
for
Space
the
Agency, all the industrial
successful
partners,
launch of
the Guyana Space
the
Center, and also my
Chinese
colleagues in
Academy of
Avio.
Yes,
oh sorry,
congratulations to all
for
of
the
those people. So
small spacecraft mission as well,
right
and at
now,
least for the
the
European Space
teams, let's
Agency and
send our
also
very
for the
best
Chinese
wishes
Academy of
to
Science,
the
their
teams,
mission with the small
the
spacecraft is just
Chinese teams
beginning,
and the European
and
teams
for
who
the
are
Avio,
flying the satellite,
this
because
is the
SMILE has to go
beginning of
through
the
a
ending
whole set of
of the
different
flight
tests
VV29,
now.
which will
Yes,
eventually will be
before going
re-entering back
towards
to Earth,
the real
which
operative
will fully
part
end
of
the
this
mission
flight.
for
We
them
can see here the
in
people
full
in the
completion.
Pandora
So that's that.
Launch Control Center, so their job is done right now. You can see
Okay, that's very good.
operational
That's very
teams in
good.
the fishbowl. There's Carol Mundell, the head of science at the European Space Agency, who came and talked to us earlier, told us all about this wonderful satellite, and no doubt over the moon, that it's now in space, going through its next phases. So let's go over now to Giulio Ranzo. Back to Giulio, the CEO of Avio. Giulio, so good news.
Yes, good news. Excellent
Okay,
news.
so let's listen the news from the CEO of Avio,
and it was able
Giulio
to
Ranzo.
deploy its solar panels, a maneuver that it was counting on executing over the first few seconds after separation. So it all went well. We're very, very happy about that, very happy about the partners. And so we should, at this point, thank them once again, the European Space Agency and the Chinese Academy of Science for their trust in us as an operator. We see applause in the room. So
yeah, so
everything has gone
the applause
well.
already heard so far.
To thank the European Space Agency for their continued support, and in particular I would like to thank the French Space Agency CNES for their assistance throughout the preparation of this flight. It all went well as we expected. And last but not least, I would like to congratulate with the Avio team for an excellent job on conducting their first mission as a launch operator.
Absolutely, massive congratulations to you and to everybody. Julia Ransom.
All right. So very good.
Thank you.
Yeah, it's not Gilio, it's Gilio.
So,
So,
Smile has wings. Smile
so
has
sorry
called
for
her and said
the,
hello.
so sorry for the,
So let's
for
now
the
go
fault,
over
a little bit of my,
Director General
of
the
my,
European
of my
Space
pronunciation there.
Agency,
You know.
Joseph Aschbacher.
Okay. So,
Hopefully, we will hear from Joseph.
okay, let's hear
In
in.
the meantime,
Today, we
Oh,
open a new window
okay,
of
need it.
understanding
This here,
into how
this here.
our planet interacts with the Sun, thanks to another successful launch of Vega C. For the first time, we will observe Earth's response to the solar wind simultaneously in X-rays and ultraviolet light. By improving our understanding of solar storms and the resulting geomagnetic disturbances, SMILE will strengthen the scientific foundations of space weather research. This knowledge is essential to better protect space-based infrastructure, critical services on Earth, and the safety of humans in orbit. In an increasingly space-dependent world, this is science with real and tangible consequences for our societies. SMILE was built on scientific collaboration and international cooperation. Over a dozen European countries have directly contributed to building the spacecraft, and more than 250 European and Chinese scientists form
de la
the
télémesure
SMILE
par la station
consortium,
NNO.
working together on the mission's scientific objectives and on the analysis of the data to come. As a joint mission between ESA and China, SMILE reflects how ESA approaches international cooperation, working openly and responsibly with clear frameworks wherever there is clear scientific benefit. I would like to thank everyone whose dedication, professionalism and expertise have made today possible. The SMILE's journey has just begun, and with it, a new chapter in our
Okay,
understanding of the
so
Sun-Earth system. Thank you for your attention.
okay, so that basically that's it. They've already that's the statement from it. So yeah, from him. So yeah, sorry.
great to hear there from
Ah.
Joseph Aschbacher and some very important words.
All right,
So
here we go.
Look, we can see the teams there, Irene, looking very happy and very
All
excited.
right. What a magnificent, perfect
no doubt
launch
be
of the
having their
Vega C
photographs
rocket.
taken,
That's a very good
We're
one.
going to have a party.
Yes, there will be a party. Because people have
Nice.
worked so hard. I mean, this has been such an important launch in so many different ways. Hoping now to hear a few words from some of the key players in today's mission.
All right.
And
Let's
the
look
industrial teams who made
if
it
there's
possible.
anything we can hear as well.
Let's go over now to Professor Qi Wang, who is the director of
Oh, all right.
NSSC
So
at the
here we go.
Chinese Academy of Sciences,
Another one here as well.
the co-principal investigator for the SMILE mission. Ione Martinez is the SMILE payload manager for Airbus Defence and Space. And Geraldine Naja is head of space transportation at the European Space Agency. Let's start with you, Geraldine. Congratulations on a very successful launch. I mean, you must be over the moon. You must be really delighted.
I'm totally delighted. It's a wonderful success. Congratulations to everyone. It has been a perfect launch. A perfect launch. Fully on time, separation exactly when it was planned, so we are extremely happy. So now, first of all, congratulations to everyone. This launch was, as I said, 3 times unique. It's the first single joint mission between ESA and China, and it's a huge success of international cooperation. Scientifically, it's a wonderful launch with a wonderful mission with so many instruments. to better understand how the sun works with our planet and interacts with our planet. And last but not least,
All right, all right. So yeah, there's like a double echo sound, but it's okay. Still perfectly legible.
another thing I want to
Anyways.
mention is, of course, that this, let's say, launch once again confirms how well suited Vega is to launch small to medium science missions. It shows that we were right to entrust SMILE to our Vega C launcher. And I would like to say this is not yet over because, of course, Vega C will continue to evolve. Soon we will have an even more powerful first stage with the P160C. We will
Yeah, that one is for the Vega C Plus variant. Oh no. Sorry, not specifically for Vega C Plus. It's going to be Vega C Block 2 as well. This one is the Vega C Block 1. Yeah, Block 1. Yeah, sorry, yeah.
Is a real day of pride for Europe, for China, I hope, for all the scientists that have been working on this mission, for all the companies, the industries that have worked both on the platform, also on the payloads. So well done, Vega C. And good trip to SMILE, which is now on its circular orbit, but will soon go into its final highly elliptical orbit.
Oh, okay. So that's basically what they said. So on the circular orbit, that one is just for the
Yes, indeed.
maintenance,
Maintenance
and also for the
Professor
troubleshooting stuff
what a
first before
fantastic partnership
and
between
before the
Europe
launch of
and
before
China.
going to the
And what an
highly
important
elliptical
milestone
orbit.
for
So basically
science.
that's it. Ah, right.
Yes, it's a really milestone. And this is the result from what we have done for more than 10 years. A huge thank you to everyone and the CAS and the ESA and the Avio and the CSA. We are proud of what we have achieved together. SMILE is a real mission now. It will be the first time to show how the solar wind meets Earth. It will study the interaction of the solar wind with magnetosphere. SMILE is more than a satellite. It's a proof of what we can accomplish for science when we work together across the globe. The adventure starts now. We are looking forward to the first image and the data.
Still waiting.
Congratulations to the entire team. Let science begins.
Okay, so that's basically it. It's a very good one.
And
all right.
Martinez, Airbus Defence and Space, led the European teams. It's been fantastic teamwork, hasn't it? You must feel very proud.
Okay, hopefully this is the final one.
It's a very emotional and proud moment for all of us. So seeing SMILE being successfully launched aboard the Vega C rocket is the result of years of effort, dedication and perseverance. So we are really happy and somehow relieved to see that we are progressing towards the next step of the missions after a long journey and very intensive on Earth. At Airbus, we want to thank you, all Airbus teams that have worked side by side together with all the industry. We want to thank the customer chain for the trust and a special mention to Avio for an excellent execution tonight. This is very important as it is the maiden flight with Avio as launch services provider. So we are willing and looking forward
just
to
like she
providing
said,
service in the commissioning and next phases, as well as we are ready to reinforce our position as key industrial partner for the future with our customers. Congratulations to all the SMILE community.
Indeed, massive.
All right. So that's it. That's good to hear. All right.
And congratulations to you, Congratulations to everybody. So there it
Yeah,
is.
so congratulations
SMILE.
to Avio for the
It sent its
for the
signal.
first
It has its solar panels. It's on its way,
for the
and
successful
so
launch of the
mission
Vega C rocket.
success.
The
Congratulations
first
to
time ever, it's
everybody
properly
involved in
in the
making it such a
under launch
success.
responsibility
Chinese Academy
to
of
them.
Science,
So
to ESA, to
successful,
CNES,
very
and all the industry
very very
partners.
very
Thanks.
not only
Yes,
just successful
and
but
best
also
wishes now
very
to the
very
operational
magnificent,
teams
very
as you
perfect,
take
flawless
on
launch of the
your new
Vega C for this
satellite.
flight
Thanks as well to the TV
VV29.
production teams for
Yeah,
making this live
and
broadcast possible.
and
And finally,
and
my
also
thanks to you,
congratulations to
Oliver,
the
for lending
European
us your
Space
wonderful
Agency and
expertise.
also
Thank
the
you so
Chinese
much.
Academy of
Thanks, Katie,
Science
for inviting
for the
me.
It's been
successful
lovely
So
having you.
now we have a smile in
for
the
the
sky.
successful SMILE
We have a
spacecraft
smile in the
uh,
sky.
deployment
We will
and
be
launch
back
as well.
next
And
time.
so that's
But
very
from
good.
me, Katie Haswell,
And Irene Cruciani. Bye.
bye-bye.
Okay, so that's it. Okay, so let's go. Let's check again. This is the launch replay of it. What happened 1 hour plus ago. So this is how it looks like. Pretty good, isn't it? Before we end this stream. Yeah. So yeah, let's go. Yeah, as it going into this into the sky, and usually if you see this launch on the daytime, you will see the there it's also leaving a pretty pretty lots of soot exhaust cloud there. Yeah, as it burns this combination of the solid of the of the solid propellant of with the um how do I say, with the ammonium perchlorate, with the ammonium perchlorate, with the HTPB, the hydroxyl terminated polybutadiene, and then eventually with the aluminum oxide powder. When you mix it up together, of course it's going to produce a good cloud amount of the soot of the exhaust of the solid rocket propellant itself. I mean, even though you technically can make a smokeless version of it, but it is what it is. So yeah, and looks like it. We've already reached the end. And yeah, thank you so much everybody for watching. This is very great time, very very productive time that we are in. Okay, for the launch itself. So well, all is good. All is good. And where is it? Where is the video focus here? Let me. Okay. So looks like they have already changed the settings here. Okay, I just already knew about this stuff just right now, but well, it's really good time. Thank you so much everybody for watching. Yeah, so I don't know, maybe I should restart this again. I don't know what's happening. Yeah, but I guess it is what it is. At least we've already ended the stream. Okay, at least we've already ended stream. I'm looking to slightly troubleshoot. I would like to know what's the problem. Maybe they've already updated something else. I don't know. Yeah, they just update right now. As of now. Oh, right. Let me try again. Let me see. Oh, they have already changed it. Yeah, so I need to get used to this to these changes. But otherwise, surprisingly, it's much more simpler setting for me to figure this out. Okay. Yeah. Okay, so it is what it is. We have already done. We are already going into live right now. So thank you so much everybody for watching. We already have done it. Yeah, we've done this kind of stream. So yeah, thank you so much everybody for watching. I'm Daniel Suguwa, your host today for the launch of the Avio's Vega C rocket for the flight VV29, carrying the SMILE spacecraft for the study of our planet Earth, and also of the Sun, of the Magnetosphere Ionosphere and sort of heliophysics mission as well, for this joint mission by the European Space Agency and also the Chinese Academy of Science. So yeah, that's very, very good, and it was perfectly successful as well. And especially this is very significant because this is Avio's first full launch responsibility of this mission. Yeah, they also make the rocket as well, and they also have to be very responsible of it. So usually it will be under the purview of the Arianespace, but well, eventually it got very better so far. So good. And yeah, I guess probably that's it. I don't have too much to say, but we shall be back again for the looks like the earliest that we can get is the Starship Flight 12, but they've already changed the time again to Friday at 6:30 a.m. here in my local time here in Sarawak in Borneo. It will be the Starship Flight 12. This one will be the inaugural test flight mission of the version 3 version. Yeah, on this version 3. All of it is the newer version. Okay. This one, the earliest it will be targeting around 6:30 a.m. here local time on in Sarawak in Borneo on 22 May 2026 on Friday. So we are universal time coordinate plus 8 hours ahead. So we are going to see that soon. Okay. And also it's going to attempt similar mission as well, but just a little bit of difference is that the first stage, the super heavy booster will be landing back around the offshore landing point in the Gulf, apparently on the so basically that's it. They don't want to fully risk out the satellite, so that's why they don't want to risk out the first stage booster because it's pretty big. You don't want to destroy the launch pad, so that's why they are going to land it around the Gulf, in the Gulf area of the Gulf of Mexico, Gulf of America, whatever you want to call it. Okay, and it will be the 22 Starlink simulators deployment as well. Okay, along with the re-entry stuff on the Starship upper stage. Okay, the 20 Starship 20 Starlink simulators will be basically inert, but the last two deployed will practically a little bit functional. This one is to scan Starship's heat shield and transmit imagery down back to operators to test methods of analyzing Starship's heat shield readiness for RTLS, return to launch site on future missions. So they will intentionally just pull out one of the heat shield tile just to evaluate the performance of the booster as well. But also yeah, we after that on the Friday at the same time as well, if there's no further cancellation or delay mission, we will also see the Strix 7 will be launched on board the Rocket Lab's Electron rocket as well. This one will be launched from the Mahia Peninsula, located around the small island of the New Zealand. Yeah, they are from what I know, they will be using the launch complex 1 one, but not sure which one. Could be A or B. We will see based on the photo given in if they give one, so maybe it will be easier for us to figure out what they are going to do. And yeah, after that it will for this we are going to cover up until this month for this schedule as well, which will be the Shenzhou 23, okay, launch. Okay, this one is the this one will be launching as well on board the Long March 2F, okay, as well from the from the Jiuquan Satellite Launch Center, from the Site 91 SLS1 as well, okay, Space Launch Site 1. We are going to see that soon, okay, but also hopefully not too long, because I do need to prepare to sleep as well on that time, okay. And then finally not really super duper finally, and then later on we will see the launch. Not 100% sure if there will be launch on this time at 12 a.m. here, but this one will be slated for the 27 May 2026 here in our local time. It will be precisely at not really 100% precisely. Probably they will shift this around 12:20, 12:30, something like that. Something like that from some sources that I can find as well. Okay, which will launch the Long March 7A, and then and then finally for this month, we will see the Amazon Leo LA07, which will be launched here on local time, would be 30 May 2026 on Saturday at 12:27 a.m. here. Okay, this one will be launching on board the Atlas 5 551 rocket configuration variant here. We will see that soon. This one will be the penultimate launch of this 551 variant. So the second to last mission of this booster. We will see that soon. So yeah, I can say I'm a little bit nostalgic about this stuff, yeah, because this thing is not going to fly any longer at this point. So yeah, it's pretty logical. You will miss this big kind of boosters here as well, especially this pre-Falcon era as well. But yeah, eventually some things will eventually coming to the end, and then later on it will be only one highly variant here. If I remember, it's going to be the only variant that will be flown, if any, if it's going to happen for the Boeing Starliner. It will only going to be the Atlas 5 N22. That one will be only with the 2 solid rocket boosters, as compared as opposed to this, to this much cooler, much higher strap-on booster, the 5 SRBs. Sometimes even much more cooler, I mean, sometimes I wish I can cover this one and then this one as well, but well, what an era, It's basically, we are basically in the sort of, how do I say, we are basically sort of in the game and in the end game era of the Atlas rocket family, So yeah, I can say I do miss this rocket. I just don't know how. I just don't know how to say anymore, because this is one of the rocket I personally have a little bit of attachment as well, something that defines my teenagehood, and to say just a little bit in in some ways also in childhood era, you know. But yeah, good things must come to end. And but not all things is way too bad. It's just like you just miss it, you know. But yeah, it is what it is. I don't think I should reeling too much on about this one. I would rather just end this stream. So thank you so much everybody for watching, and yeah, thank you so much everybody. I will say this one more time again. I'm Dennis Suguwa, your host today for the launch of the Avio's Vega C rocket for the flight VV29, carrying the SMILE spacecraft for the joint mission of the European Space Agency and also Chinese Academy of Science. And yeah, for this mission, preliminary it's successful, and then separated to the circular orbit around 705 kilometers, something like that, if I remember. Yeah. So and then eventually they will be the spacecraft will be boosted to the using its own onboard propellant thruster, which will be raising its orbit to the final orbit of the 5,000 kilometers by 121,000 let me see, 121,182 kilometers of the orbital altitude. So that's going to be it. So yeah, thank you so much everybody for watching, and I shall see you guys and everyone here back irrespectively on the next stream. So thank you so much everybody for watching. Yeah, sorry for that. I'm still slightly coughing here, but please take care. Don't be sick like me, okay? Please take care of your own health, and yeah, and if you got sick like me, please take a bit more rest here and there once in a while, okay? Don't just be like me. So thank you so much everybody for watching, and bye bye. We shall see you soon on the next stream. And that's it. See you guys again back. Bye bye. And that's it. We have already finished. You can now safely safely, how do I say, safely you can now safely close this stream. Yeah, I'm going to use the Windows announcement, Windows 95 like announcement 3.1, something like that. So yeah, you can safely quit from this stream because we have already finished. So yeah, thank you so much, and see you soon. Bye bye, and stay safe and stay healthy. Unlike myself right now, currently slightly coughing, slightly sick, but well, it is what it is. Thank you so much. Bye bye.